Hello everyone, welcome back to our channel, Problematical. Today we'll discuss the solved examples of your NCERT second chapter, Relations and Functions, class 11th Maths. So the first question is, if x plus 1, y minus 2 is equals to 3, 1, find the values of x and y. So two ordered pairs are given to you and they are equated. You have x plus 1, y minus 2 as the first ordered pair. It said that it's equal to 3, 1. Two ordered pairs are equal if their corresponding first elements are equal. The first elements would be x plus 1 and 3 if their corresponding first elements are equal, and their corresponding second elements are equal, which gives you x is equals to 2 and y is equals to 3. These are the values which are asked, x and y. Second, if P and Q are given to you, form P cross Q and Q cross P. P cross Q would be the ordered pairs such that first element with first element of the other, second element of the first element of the other, third element of the first, second element of the first element of the other. So your first elements of each of the ordered pairs should belong to your set P, and the second element of each of your ordered pairs should belong to your set Q. Since Q is a singleton set, you will have only three elements in P cross Q. In Q cross P, your first element should belong to Q, and your second element should belong to P, and you should write all such combinations. Again, you have only three elements. Are these two products equal? Now, is A, R equal to R, A? No, because first element is A over here, first element is R. Only if the corresponding first elements of two ordered pairs and the corresponding second elements of two ordered pairs are equal, we can call the two ordered pairs as equal. So no ordered pair in P cross Q belongs to Q cross P, or vice versa. So P cross Q is not equals to Q cross P. Example third. A and B, C sets are given to you. You have to find these values. First, A cross B intersection C. This is equals to A cross. Let's calculate B intersection C. Now, B value and C value, C sets. These two sets has only element 4 in common. So, this is element 4. This will be equal to 1, 4, because A has 3 elements, 2, 4, and 3, 4. Second, A cross B intersection A cross C. Now A cross B, what is A cross B? A and B, all the elements which are common in this, which can form ordered pairs over here. 1, 3, 2, 3, 3, 3, 1, 4, 2, 4, 3, 4. Intersection A cross C, which is 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, 3, 6. Now you have to find the common elements amongst these two. So 1, 3 is present over here, it's not present here. 2, 3 not present here. 3, 3 nope. 1, 4. Now 1, 4 is present in these two sets. 2, 4. 2, 4 is also present. 3, 4. We also have 3, 4. So these are the only three elements, three ordered pairs, which are common amongst the two sets. So we'll write these as 1, 4, 2, 4, 3, 4. These are the three elements of your second part. If you can observe, your right hand side of first and second are same. You have 3 elements and these are exactly the same. So from this, you can see that this equation is equals to this equation. If you further observe, then you can find that here distributive property is used. A cross B intersection C can be written as, opening this bracket, this is common for the bracket. So A cross B, middle sign intersection, A cross C, which is exactly your second value that you were asked to calculate. So here distributive property follows between first and second examples. Let's calculate third and fourth examples. A cross B union C. This is equals to A cross, what is B union C? B united with C. So we'll have 3, 4, 5 and 6. Here A has 3 elements. So let's write all these elements formed. 1, 3, 1, 4, 1, 5, 1, 6. 2, 4, 2, 3, 2, 5, 2, 6. 3, 3, 3, 4, 3, 5, 3, 6. Fourth, A cross B united with A cross C. Now you've already calculated A cross B and A cross C. So we'll write them together. We've already calculated A comma C. This is your value of A cross B and this is your value of A cross C. So uniting them means writing all the elements which are repeating only once. So the circle ones are the elements which are repeating. So I'm directly writing the answer over here. These elements 1, 3, 2, 3, 3, 3 will be as it is, or in uniting section what we do is we write the first set as it is. So here we'll write the first set as it is. 1, 3, 2, 3, 3, 3, 1, 4, 2, 4, 3, 4. Now from the second set, we write only those elements which are uncommon. So excluding the circles, all the other elements have to be mentioned. So it is 1, 5, 1, 6, 2, 5, 2, 6, 3, 5, and 3, 6. Okay. Here also, if you can observe, these two sets are equal. One, 3, 1, 3, 1, 4, 1, 4, 1, 5, 1, 5, 1, 6, 1, 6, 2, 4, 2, 4, 2, 3, 2, 3, 2, 5, 2, 5, 2, 6, 2, 6, 3, 3, 3, 3, 3, 4, 3, 4, 3, 5, 3, 5, and 3, 6. So as you can see, these two sets are equal. Next, if P set is given, you have to form a set of P cross P cross P. So we know that in this case, we'll write P 3 times, just to be able to form it in a simpler manner. So P cross P cross P will have triplets in it. 1, 1, 1, 1, 1, 2, 1, 2, 1, 1, 2, 2, 2, 1, 1, 2, 1, 2, 2, 2, 1, and 2, 2, 2. So first element as it is, and then you'll write both these elements. So 1 is written over here, 2 is written over here. Then first element as it is, and instead of the first, you'll consider the second element, first and second elements, and 1 and 2, 1 and 2. Then change this first to second element. Second element, after second element, first, 2 and 1, 2 and 1, 2 and 1, and it will have this. If I have two values, this one, and this is your second value. Again, 2 over here, and instead of 1, you'll choose 2, 2 and 2. With 2, 2, you have two values, 1, 2, 1 over here, 2 over here. Next, if R is a set of all real numbers, what do the Cartesian product or R cross R and R cross R cross R represent? R is a set of real numbers. So all the real numbers can be represented on a number line. So R represents a set of real numbers, means R resembles a number line. This is one number line. If R cross R is considered, you have to consider the combination of this R with another R. That means you have to consider the combination of this line with another line. So this is where we come up with x-axis and y-axis. They are two real lines. They are two lines which contains all the points of real values. So R cross R resembles or represents a two-dimensional coordinate system. Or R cross R represents the coordinates of all the points in two-dimensional space. Similarly, R cross R की जगह, if we had R cross R cross R, here you have x, y, z axis. So this represents a three-dimensional space, the coordinates of a three-dimensional space. Now you can even write the this R cross R and R cross R cross R in self-builder form. So R cross R will be equal to a set of x, y. You know that in 2D on a graph paper, you have two values, two numbers representing each point, where x, y belongs to real value. Similarly, your R cross R cross R represents a triplet, ordered triplet of x, y, z, where x, y, z belongs to R, real value. Next, if A cross B is given, you have to find A and B. Now we know that A would be all the elements which come first. So A is the first set. So all the elements which come first in the ordered pair. That's why A can be written as a set of B, Q, because there are only two unique values here. Similarly, B is a set of all the elements which come at the second position of your ordered pair. Here they are Q and R. Sorry, did I write here Q? It has to be M. Yeah, P and M in the first position, Q and R in the second position. Next, A set is given to you. Define a relation R from A to A by R is equals to x, y, such that y is equals to x plus 1. So a relation R is given to you. You have to define this relation R. Means a set builder form of relation is given to you. You're supposed to write it in Cartesian form. In roster form. In roster form, you have to find the elements of the set A. And you have to find the elements of set R. A is equals to 1, 2, 3, 4, 5, and 6. Now here, this is a relation from R to R, from A to A. I make so many mistakes. Here R is a relation from A to A. That means if every element of this A be X and every element of this A be Y. Because your R is defined from X to Y. X, comma Y. X represents the first elements of set and Y represents the elements of the second set, and both sets are A over here. So when you place these values of X, we can say that X can be 1, 2, 3, 4, 5, and 6. So your relation R is written as X key value can be 1, it can be 2, 3, 4, 5, or 6. When X is placed as 1 over here, your Y value comes down to be 1 plus 1, which is 2, 1 greater than the value. When X is equals to 2, Y is equals to 3, 2 plus 1, 3. When X is equals to 3, Y is equals to 4, 4, 5, 5, 6, 6, 7. Now, as you can see, the last element, 6, 7, your Y is supposed to be A. That means your Y can also hold any value which is in the set A. 1, 2, 3, 4, 5, and 6. It does not have a 7 value. That's why we will eliminate this particular element. It will not exist. So X cannot have the value 6 because for that value of X, your Y does not exist. In this question, you have to depict this relation using an arrow diagram. Write down domain, codomain, and range. So we'll do the second part first. We'll write down the domain, range, and codomain. Your domain of R is a set of all the first values of your ordered pairs, which are 1, 2, 3, 4, and 5. Your range of R are all values which are the second values of your ordered pairs of R, which are 2, 3, 4, 5, and 6. Your codomain of R. Now, these are all the values which come here. All the values that your relation is pointing towards. The second set. Second set is A. A has 6 values. So a codomain also has 6 values. Now, for the arrow diagram, let's draw the two sets. Your relation is pointing from A to A. That means in both the values, we'll write 6 elements. Let's write them in sequence. Now, when X is equals to 1, Y is equals to 2. So 1 to 2. Similarly, when X is equals to 2, Y is equals to 3. When X is equals to 3, Y is equals to 4. 4 to 5. And 5 to 6. An arrow is to be placed on each of these lines pointing towards your codomain. Okay. By observation, this is your A and this is also your A. Any element over here in the second one is your codomain. All the values that your 1 to 5 are pointing towards will be your images, and the set formed will be your range of R. Next. Example 8. Now here figure 2.6 is given to you adjacent to the statement, shows a relation between sets P and Q. Write down the relation in set builder and roster form, and what is the domain and range. Now by observation we can write it in roster form first. The elements so formed in the relation would be ordered pairs from 9 to sets P and Q, and your relation is from P to Q. So from P to Q, 9 comma 9 is pointing towards 3 and 9 is pointing towards minus 3. So 9 comma 3, 9 comma minus 3, 4 comma 2, 4 comma minus 2, 25 comma 5, 25 comma minus 5. Now to write a relation in set builder form, we need a relation between the ordered pairs. That means if you consider the first ordered pair as x and the second ordered pair as y, if you observe 9 is 3 square, 9 is minus 3 square, 4 is 2 square, 4 is minus 2 square, 25 is 5 square, 25 is minus 5 square. So x is y square. This is the relation between the elements of your ordered pairs. Your relation R can thus be written in set builder form as a set of all the x comma y ordered pairs such that x belongs to P, y belongs to Q, and x is equals to y square. So this is writing it in roster form. Writing it in set builder form. What is domain and range? So domain of R will be all the first elements, which is 9, 4, 25, and range of R will be equals to 5, minus 5, 3, minus 3, 2, minus 2. All the second values of your ordered pairs. Next. A and B are given to you. You have to find the number of relations from A to B. So, number of relations from A to B. You do not have to write the relations. You just have to find the number of relations. If you want, you can even find A cross B and then form the relations between them. But you can also use a formula for it. We know that number of elements in A is 2 and number of elements in B is 2. We know that number of elements in A cross B will be equal to number of elements in A into number of elements in B, which is equals to 2 into 2, which is equals to 4. Now, number of relations, the relations itself are formed after A cross B, after the Cartesian product is known to you, and the Cartesian product represents all the elements of Cartesian product would be the maximum relation that can be formed between A and B. However, other relations will be subsets of this A cross B set. So, how many subsets can you form of A cross B? So, any subset of a set is represented by a power set. Therefore, the number of relations from A to B is equals to total number of subsets of A cross B. Now, total number of subsets is 2 to the power the elements of these sets, which is 4. So, the total number of relation from A to B is 2 to the power 4. Next. 10th. Let n be the set of natural numbers and the relation R is defined on n such that R is given as x comma y, where y is equals to 2x, x comma y belongs to natural numbers. You have to find domain, range, and codomain of R, and then you have to determine whether this is a function or not. Now, anything is a function only in specific, only some relations are functions, and anything is a function only if the element of set A or the element of your first value of your ordered pair has one and only one image, which is your second value of your ordered pair. Let's check for this particular section. First, what you're supposed to do, you have to find the domain, range, and codomain of R. So let's write the relation R first if possible. It's not possible because x and y are n. That means there are infinite values. Okay, let's write a few of them. You have R is equals to natural number, so it's like 1. X key value can be 1. It starts with 1. When x is equals to 1, your y is equals to 2. When x is equals to 2, your y is equals to 4. X is equals to 3, y is equals to 6. X is equals to 4, y is equals to 8. X is equals to 5, y is equals to 10, and so on. As you can see, you can find a pattern which is y is equals to 2x. It also means your domain will have values like 1, 2, 3, 4, and so on. So can you see that the domain of R is a natural number, is a set of natural number? Next, range. Your range would be all the values, all the images formed, all the values that these domain values are pointing towards. So your range of R would be values like 2, 4, 6, 8, 10. As you can see, these are even numbers. So this is a set of even natural numbers. Now, it says that in a particular a relation is a okay, you also have to write the codomain. Let's write codomain now as well. Codomain is all the values that this relation is pointing towards. Now, y is also a natural number, and all the values that y can possibly have would be all natural numbers. So this is also natural numbers, set of natural numbers. Now, is this relation a function? A relation is function if every first value, okay, if every first value has a unique second value. That means if you write 1 over here, you're getting 2 over here. There shouldn't be any other element over here where you have 1 and any other value apart from 2 at the second position in this particular set. If you place 1, you should always get 2, because that is what you are expecting from an equation as such y is equals to 2x. As you can see, all the first values are unique in nature and they have a unique second value. So this relation is a function. Is a function since every natural number, at the first position you have, your domain is a natural number. Every natural number n, we are letting it to be n, has one and only one image. Next, examine each of the following relations given below and state in each case give reasons whether it is a function or not. So you have to examine the relations given below and state in each case giving reasons whether it is a function or not. Okay, so let's check whether the first relation is a function or not, and whether it is a function or not, you have to give reasons for it. R is equals to 2, 1, 3, 1, 4, 1, 4, 2. So whenever you have unique first position values or first elements of different ordered pairs are different, then you can directly call it as a function. Since 2, 3, and 4, which are your domains of domain of your relation, are elements, are domain elements of R having unique images. Hence, R is a function. Next, R is equals to 2, 2, 2, 4, 3, 3, 4, 4. Now here you can clearly see that one value of which is the first element of these two ordered pairs is same. One value has two different values. That means when you place the value of x, you are sometimes getting 2 as y and sometimes getting 4 as y. This is not required. This means that this relation is not a function. So a domain value 2 has two different values. It does not has a unique image, but it has two different images. This 2 value has image 2 and image 4. Since the same domain element 2 has two different images, two and 4. Hence, this relation is not a function. R is equals to 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. Now here you can see that all the domain elements are unique in nature. You have domain elements like 1, 2, 3, 4, 5, 6. All domain elements are unique. Hence, all these elements have unique images. So you can write the first condition itself. Since 1 to 6 are domain elements of R having unique images, therefore R is a function. Next, now let n be a set of natural numbers. You have to define a real valued function. Function is from n to n by f of x is equals to 2x plus 1. Using this definition, you have to complete the table given below. So we know that your f of x is equals to 2x plus 1. You have to complete the table, means you have to find the values of f of 1, f of 2 till f of 7. So let's calculate the values. F of 1 is equals to 2 into 1 plus 1. That means in place of x, you have to write 1, which is equals to 2 plus 1, which is equals to 3. F of 2 is equals to 4 plus 1 is 5. F of 3 is equals to 3 into 2 plus 1, 7. F of 4 will be equals to 8 plus 1, 9. F of 5 will be equals to 10 plus 1, 11. F of 6 will be equals to 13. F of 7 will be equals to 15. Placing these values, we get 3, 5, 7, 9, 11, 13, 15. Define the function f from R to R by y is equals to f of x is equals to x squared. X belongs to R. Complete the table given below by using this definition. So your definition is f of x is equals to x squared. So whichever value of x you have, all you have to do is take the square to get the value of y. So minus 1 square, 16, minus 3 square, 9, 2 square, 4, 1 square, 1, 0 square, 0, 1 square, 1, 2 square, 4, 3 square, 9, 4 square, 16. Draw the graph of f And what is the domain and range of the function? Now, domain would be your relation f is from R to R. That means R represents the value of x, and this second R represents the value of y. Your first R can, your x can hold any value, which is real value. So your domain of f is real, or it can also be written as a set of all x such that x belongs to R. Similarly, your range of f, this is x squared, again where x belongs to R. This R is the second R. Next, draw the graph of f. So let's draw the x and y axis. What do we have here? Hold on. Yeah. So what do we have here? You have to find out the graph of f. So let's try and plot these values. For x is equals to 0, your y is equals to 0. For x is equals to positive values, your y is incrementing and it's reaching a great height in a form of a curve, exponential rise. Then as you go negative, you're getting a positive value of y. So this curve would look something like this. You can place 1, 2, 3, 4 values on x and y axis. Draw the graph of the function r x to x, f r to r, defined by f of x equals to x cube. You have to draw the curve for f of x is equals to x cube. When x is equals to 0, your x cube, which is your f of x, is equals to 0. When x is equals to 1, your x cube is 1. X is equals to 2, x cube is increasing. X is equals to minus 1, x cube is equals to minus 1. X is equals to minus 2, x cube is equals to minus 8, and so on. So when x is positive, your y is positive. When x is negative, your y is negative, which means you're covering first quadrant and third quadrant. Here, the value of this x is increasing sharply, and here it is decreasing sharply. This is the form of curve that you get. Next, define the real valued function where f is equals to r minus 0. Now, r minus 0, this represents your domain can have all the values of real function, all the real values except for 0. That means you are never placing x is equals to 0 over here. Sorry, I wrote 0 over here, I guess. Let's change it to 0.25. Yeah. So you are never placing the value of x as 0. And for x, for these values, your function is f of x is 1 upon x, that is the value of y. And you have to complete the table using this definition. Then you have to find the domain and ranges of the function. So at x is equals to minus 2, this will be minus 1 by 2, which is minus 0.5, minus 0.5. Let's change this to this one here. When x is equals to minus 1.5, your y is equals to minus 1 upon 1.5. 1.5 is 3 by 2, so it is minus 2 by 3. In decimal, it will be minus 0.67. When x is equals to minus 1, this is minus 1. Is it minus 0.5 minus 2? 0.254 inverse. All you're doing is finding the inverses. 1 inverse 1, 1.5 inverse 0.67, 2 inverse 0.5. So this is it. Now you have to find the domain and range. Complete the table. You have to define the real value function. There's no way it's written that you have to draw it. However, it's inverse function, so you can easily draw it. So it means that when x value is increasing from -1 to 2, your y value is also increasing, but at a different, steeper pace. Domain would be all the possible values of x, which is again, it can be a real value minus 0. That means you can have any value except for 0. When you place these values, which values of y do you get? That means what would be the range in such a scenario? Your range would be again any real value except for 0. You'll never get a 0 because to get a 0 in place of y, to get y is equals to 0, you should have x is equals to infinity. And that is something that you're not placing here. So if you were to draw this on your x and y axis, then such a graph would look like at x is equals to 1, your y is equals to 1. At x is equals to greater than 1, 1.5, your y is decreasing. At x is less than 1.5, your x 0.5, your y is incrementing. So this would never reach 0, but this would form a curve something like this. Yeah. Just 1 second. Give it a third try. Similarly, it will look something like this. It will never touch infinity at positive x, y, or positive, negative x or y axis, but it will definitely become closer. Next, let f of x is equals to x squared, g of x is equals to 2x plus 1 be the two real functions. You have to find f plus g of x. That means what will be the addition of the two functions. Now, f plus g of x would be equivalent to f of x plus g of x. That means adding the two functions. This is x squared plus 2x plus 1. F minus g of x would be f of x minus g of x, which is x squared minus 2x minus 1. Fg of x would be equivalent to f of x into g of x, which is x squared into 2x plus 1. This is 2x cubed plus x squared. F upon g of x would be f of x upon g of x. This is x squared upon 2x plus 1. The only condition over here is your x should not be, denominator should not be equals to 0. So x should not be equal to minus 1 by 2. Next, let f of x is equals to root x, g of x is equals to x be the two functions defined over the set of non-negative real numbers. Now, set of non-negative real numbers, which means n can never be a negative value. And then you have to find these values. So again, it's the same. F plus g of x will be equals to f of x plus g of x. This is equals to root x plus x. f minus g of x is equals to f of x minus g of x. This is equals to root x minus x. F into g of x will be equals to f of x into g of x is equals to root x into x is equals to x root x. F upon g of x is equals to f of x upon g of x. This is equals to root x upon x. So that concludes your examples. Thank you.